Welcome back friends in the second part of log and antilog value calculation, and in this video we will discuss the use of log and antilog table to calculate these values. In the previous video we have already learned how to use computer online or offline mode or our scientific calculator or smartphone calculator to find out these log and antilog value. I hope all of you have seen log and antilog tables at the end of many books. And today we will see how to use these tables. First we will see the log tables. This log table, you can see there are different rows and columns. In rows it starts from 1, 1.5, 1.2 to 9.9. Whereas in logarithmic table it starts with 0 to 9, and at the end there is one special table which is known as mean difference table. So first let's take some example to calculate the log value. Suppose you want to find out the log value of 2, 20, 200, 2000 or 20,000. First we will find out where 2 is mentioned, and if we know the value of log 2, it's very easy to calculate value of log 20 or 200 or 2000 or 20,000. If our value is 0 to 10, we have to write 0 before the decimal. If it is between 10 to 100, we have to write 1. If it is 1000 to 10,000, we will write 3, and so on. For 20, we simply write 1 and then put the decimal point, and then again the same value 0.301. For log 200 it is 2.301, for log 2000 it is 3.301, for 20,000 it will be 4.301, and so on. Here we have to calculate the log value of 12, 123, 1234, 12,345 and 1,23,456. So the first thing what we have to find out is the decimal value. So if it is between 10 to 100, so first we have to write 1 plus, because there is no number after 12, so we will check on 0, it is 0.0792. Therefore the log 12 will be 1.0792. For log 123, first you will have to write 2 plus then 12 value on 3, it is showing 0.0899. So the final value of will be 2.0899. Similarly, if we want to calculate 1234 log value, first you will write 3, then the 12 log value at 3 level, it is 0.899, and now the role of this mean difference will come, because there is one more number after 1, 2, 3, it is 4, and for that 4 we have to write the number which is mentioned in mean difference, and that is 14. But we will not write directly 14. We have to divide this number by 10,000 and then we have to add it with the other number. The final log value will be 3.0913. In case we want to calculate the log value of 12,345. So the first thing, there are 5 numbers, so we will write 4. Then 12 on 3, like we have already done, it's 0.0899. Then the 12 mean difference on 4, it is, we have already done, it is 0.0014. But now we have one more digit, that is 5. For that we again will see the mean difference, but this time, the first time we will have to divide it by 10,000, in next it will be with 1 lakh. So the actual value which we have to add with this value is 0.00017. Final log value will be 4.09147. Same way we can calculate the log value of 1,23,456. Again the first, there are 6 digits, so we will write 5, then 0.0899 for 12 on 3, then 0.0014 for mean difference of 4, 0.0017 for mean difference of 5, and 0.000021 for mean difference of 6. So the final value will be 5.091491. Sometimes you have to calculate the log value of decimal. Suppose we have to calculate the log value of 5.7. There are less than 10, so first we will mark 0, then 5.7 at 0 level it is 0.7559. If it is 57, the first thing we will write 1, and then again 5.7 value on 0 is 0.7559, it will 1.7559. But if it is 574, so in that case first we have to write 2, and then we have to check the 5.7 on 4. It is 5789. The final value will be 2.7589. Similarly, for log 5747, we have to calculate this mean difference. First we will write 3, then 0.7589, and then mean difference of 5. As we have already done, the final value will be 3.7594. And if we are just changing the decimal, it was 5747, it is 3.7594. For log 574.7, it will be 2.7594. For 57.74, it will be 1.7594. So the after decimal there will be no change, but before decimal we have to change the our values depending upon whether it is less than 10 or in between 10 to 100 or 100 to 1000 or 1000 to 10,000 and so on. Suppose we have to calculate the value of log 57.474. Again, if it is 57, first we will write 1, then 5.7 on 4, it is showing 0.7589. Then on the mean difference on 7, it is 0.0005. Mean difference on 4, it is 0.00003, and same on we can also find out the value of log 5.74742. It seems complicated, but after practicing it you will be used to it. I request you to practice it and cross check your values. You can take any one of these values, or you can take any other value by your own assumption and try to find out these value by using calculator, by using internet, by using MS Excel, or by using these log tables. Now we want to calculate the antilog value with the help of this log table. Like log table, there are also two antilog tables, and again there are antilog value as well as there are mean difference column separately. Let's take some example where we have to calculate the antilog value of 0.053 or 1.053 or 2.053. We have to consider the only 2 point after decimal, it's 0.05, and after that it's mentioned 3. So we have to consider this row only, and the value of 0.05 at the level of 3, it is showing 1130. If it is 0 before the decimal, we have to multiply by 10. If it is 1, we have to multiply by 100. If it is 2, we have to multiply by 1000. If it is 3, we would have to multiply by 10,000 and so on. So the value will be remain same, only the decimal point place will be changed with this number. Similarly, if we want to calculate the value of 0.53, 1.53, 1.532, 1.5327, 1.53275 and so on. So first we have to find out the where it is mentioned 0.53, and at 4.53 we simply write the value which is mentioned in the table and multiply it by 10 because there is no value before decimal. If it is mentioned 1.53, we have to multiply by 100. If it is 1.532, in that case we have to check this 0.53 in the column of 2, and the value is 0.3404, and it is mentioned 1, so we have to multiply by 100, and finally we will get 34.04. Similarly, for antilog 1.5327, in this case first we have to find out the 0.53 value at 2, that is 0.3404, and then again with mean difference of 7. After dividing by 10,000 it is 0.0006, and then multiply, because it's mentioned 1, we have to multiply by 100, we will get our value, that is 34.10. and just like we have applied for log case, again if our mean difference is one more decimal, first we have to divide it by 1000, or like in the next example 1.53275. in this case we have to check the one more mean difference at 5, which is mentioned here 4, and this 4 have to be divided by 1 lakh, and then this has to be multiplied by, because it's 1, so the final value will be 3.4104. Similarly, if it is mentioned 3 so the value will remain same, 34104. If it is 1, we have to put the decimal after 2 digits. If it is 3, we have to put the decimal after 4 digits. The case where we are using the different log and antilog tables. Now we have to find out the log and antilog without tables. It is supposed to remember the basic concept of logarithm. The log value of 10, 100, 1000, 10,000 are 1, 2, 3, 4 and so on respectively. You are also supposed to remember the log values of 2, 3, 5 and 7. The log value of 2 is 0.3010. The log 3 will be 0.4771. Log 5 will be 0.6990. Log 7 will be 0.8451. And there are these three basic operation of log. In multiplication of log will converted into addition, like log x into y become log x plus log y, whereas division will become subtraction, log x over y will become log x minus log y, and the log x to the power y will become y log x. So let's take some example to understand this concept. Suppose we have to calculate the value of log 4. Log 4 can be written as log 2 into 2 or log 2 plus log 2, and then simply write the value of this log 0.3010, and the final value will be 0.6020. Similarly, for log 20 we have to put only 2 into 10 instead of 20, and for 2 it is 0.3010 and for 10 it is 1. Similarly, for 300 we can convert it into 3 into 100, and similarly we can calculate it easily like in the case of log 20. We can also use this method for even some other number like 240. Like log 240 can be written as 2 into 2 into 2 into 2 into 3 into 5, or it will become 4 log 2 plus log 3 plus log 5. After putting all the value, we can calculate it as 2.3803. Whereas for log 1.5 we can convert it to 15 over 10, or 15 can be rewrite as 3 into 5, or we can simply write log 3 plus log 5 minus log 10, and the final log value will be 0.1761. But sometime even we get some hint, like if log 2.57 is this much, so what will the value of 257? 257 will be, there are 3 digit numbers before decimal, so we have to write 2, and the after decimal value will remain same. Similarly, for 4257 it is 3.6291, this 6291 will remain same, only difference that instead of 3 we will write 1. Similarly, for 511, if you want to calculate the value of 1022, in this case we can rewrite it at 2 into 511, and log 2 value we already know, and we after putting the log value of 511 we get to know that the exact value is 3.0091. Sometime examiner want us to calculate the antilog value. Like in this case, log 72.3 is mentioned at 1.8591, and examiner want us that we have to calculate the antilog value of 0.8591 or antilog value of 4.8591. So in this case we have to simply write 723, and because if it is 0 in the first case, we will put the decimal after 1 digit, and if it is 4, we will put the decimal after 5 digits. So this is all about the use of log and antilog table to find out the log and antilog value. I hope now you know the concept of calculating the log and antilog value. In our previous video, we have discussed the use of computer, scientific calculator and mobile smartphone calculator, and in this video we have used our traditional log tables. I hope this video will be helpful for you in calculating the various other operations. Thank you for watching this video. Please press bell icon to subscribe my channel, like and share this video. Jai Hind.